Hi everyone, and welcome back. This is day 2 of the 12 days of machine learning miss, which is not that great sounding. I really wish that machine learning had a more, a better ring to it. Because, yes, captions are good. Yes. Okay. Hello, generic crew, third tier gaming, Strawberry Jesus. Welcome. Today we're going to be talking about logistic regression. So let's take a look really quick, if it still works, at the schedule. So as you can see, today is day 2, and we are moving on from linear regression to logistic regression. And this is going to be a little bit of a step up in terms of difficulty from yesterday's stream, but don't panic. We'll get through it together. There's a couple reasons why logistic regression is harder, I would say, than linear regression. And one of the big reasons is the math. So we're going to be spending a little bit more time on our whiteboard, blackboard, whatever, and a little less time with the code, because the code is actually the simplest part here. But I think, one of the things that I want to avoid is I don't want you to come away from this series of streams with the same knowledge that you might get. Oh goodness, thank you for hosting Third Tier Gaming. I don't want you to come away from this with kind of your average bootcamp understanding, which is like, here's the scikit-learn methods that you need to do these various models. Like, I really want to try and see if we can kind of push that a little bit and really start to understand when and why we apply these models and kind of where some of the math comes from. But that does mean, I'm sorry, friends. Well, I'm not sorry. I love math, and you should love math too. So we're going to be doing a little bit more of the math today. So to start us off, though, are there any leftover questions or anything from linear regression? Because we're going to be starting we're going to use a little bit of what we learned yesterday with linear regression to inform how we approach logistic regression. Yay! Hi, Stealthar. Yes, fundamentals-based learning is the best kind of learning. And I'm going to avoid as much as possible some hand waving. That happens, I think, a lot. But what that means is that it's going to be a bit of a deeper dive. We're gonna have to use some Greek letters. Like, there's going to be some math that happens. But I promise, if you stick with me, you'll come away from it with a better understanding. So, I guess with that, let's move right into. Oh, don't make that scared face, Loafbone. Not when it comes to math. This is a pro math channel. Okay. So, yay, logistic regression. Hi, Ona. Welcome. Also, please bear with me. I'm feeling a little under the weather today. I think I'm fighting off every winter I get some kind of cold. And so I'm going to be drinking heavily from my delicious mug, which also I realized is green. So my green screen it's maybe I can hold it over math and you can see the math like through my mug. Anyway, I'm going to spill hot tea on myself if I do that. Hi, Cassie. How are you? Okay. I love tea. All right. So, where we're gonna start today is let's recall for a moment. Let's recall kind of the pattern that we looked at yesterday with linear regression. Also, how was my handwriting? Can people read my handwriting? Was it? Because I made this like a thicker text because I thought maybe people would be able to read that a little bit better. But seriously, if you can't read something, I will not be offended. Tell me to fix my shit. Like, I will be better, I promise. All right. This is kind of what we talked about yesterday. This was the pattern, right? We got some X. This is our inputs, features, or independent variables. Actually, hold on. I'm going to move some things around. I like Euler, but I don't think they'll be... Oh no, my cord is... Don't unplug it in the middle of the stream. Okay. All right. I think I moved this closer. There we go. And this is Y, which is our target, our label, whatever you want to call it, also our dependent variable. All right. And the whole point that we learned yesterday, right, was linear regression. Let's find some equation of a line that approximates the relationship between our x's and our y's. You ever heard Bueller? Bueller? I'm trying to make it sound like boiler. No humor for me today. Okay, none of that. Boiler. Oh, there you go. That's better. So, if you remember yesterday when we were talking, I said that our linear regression implies some stuff, right? It implies, wow, that's a chonky text. Okay. It implies that there's a linear, obviously, relationship, right? Between x and y. So what happens when there isn't? And in particular, there's one thing that I told you yesterday that's really crucial for today, which is that a linear regression, our line, can be used when the thing we want to predict, this y, is continuous. That means it could have any number of values in a range, right? So prices, temperatures, weights, those are all things that, oh, my cold, I'm sorry. Those are all things that you can use a linear regression for. But no, we're not talking about linear regression today. None of this, none of that, no more lines. We're done with lines. We're too cool for lines today. So, the situation that we're looking at today is where the thing that we're trying to predict is actually a category. Please switch. No, I want green. Ooh, lag. It's bad enough when your blackboard has lag. Did you take a bite of Italian and beat it up till it's late? So, let's see here. What we're going to be looking at today is a slightly different situation. No, go away. All right. And that is, like I said, where we are trying to predict. Oh, what is up with this? Come on, little bean. You can do it. No, little blackboard. I believe in you. Don't fail me now. But instead of having a whole bunch of values here for our y, we're going to have two values, 0 and 1. And what that means is that we're going to have a bunch of x's that give us 0, and we're going to have a bunch of x's that give us 1. And I do that terribly, so bear with me. Oh, it doesn't like the erasing. Oh no. Okay. We are a good function. We cannot have the same x giving us multiple y's. No, we're going to be good. We're going to be good mathematicians today. All right. And so this is really the pattern that we're trying to work with. And if we try to fit a line to it, like, we're gonna have a bad time no matter how hard we try. It's like, a line isn't gonna work. We can't be linear with this. And so instead what we're gonna be looking for is a function that does this. Oh yeah. Look at that, that's perfect. And this beautiful S shape has the wonderful name of a sigmoid function. I know, ooh, so fancy, it's fancy. And so a sigmoid function, just like before when we had our line, and I'm gonna draw the line briefly for comparison, right? We had this equation y equals mx plus b. Now this didn't scare anybody really, because it's something we all learn at some point. We learn the equation of a line. The equation of a sigmoid is gonna look scarier, but it's not scarier. It's just something that we didn't memorize because for the most part, when you're learning y equals mx plus b, you don't need to learn a sigmoid. You don't need to learn how to make an S shape. Lines, however, you need lots for like lines tangent to curves and all kinds of wonderful things. And so for that reason, don't panic. I'm going to just give you the equation of a sigmoid. But just like y equals x squared, y equals mx plus b, y equals any other number of functions, it's just how we make this shape, okay? It's nothing fancy, I promise. And so sigma, so sigmoid, right? We're gonna have nothing fancy, okay? I promise. Don't panic when you see the math. Don't run away. You weren't scared of y equals mx plus b, so there's no reason to find this intimidating, I promise. It just looks a lot fancier. In fact, I'm going to rewrite this y equals mx plus b in the slightly more intimidating form that we learned yesterday, which would be kind of y of x equals, I used betas yesterday, right? Beta 0 plus beta 1x. Thank you so much. Love cats, but allergic to them. Thank you for following. I'm so sorry you're allergic to cats. I love cats. I'm also mildly allergic to them, but I love cats. I also love dogs. I love like equal opportunity animal lover. Also, is that an I or an L? Mal's Depot. I think it's an L. Mal's Depot. Thank you for following. If I start to lose my voice, I will do my best to like power through. And I won't blow my nose on stream like some kind of pleb. All right. Okay. I know the fancy mug. It's like, I love that I got it because it was all Christmassy and I thought that would make everybody happy. And then I promptly forgot I have a green screen, so. Okay. Sigmoid function. So there's one problem here with our sigmoid function. And I'm gonna actually ask chat. What do you think we're missing here with the way that we've written sigmoid, our sigmoid function definition here? We are missing something kind of important that we talked about yesterday. Root guy, you say, wow, sigmoid got my first kiss to this function. How? That's a power move, my friend. And thank you, Sanbu, for following. So what are we missing? Also, I love the Christmas colors. It's totally unintentional, but it's just happening. Makes me happy. All right, let's change this while I'm waiting on y'all to answer. So we've got some more Blackboard-friendly colors. What are we missing here? Yes, Onad, coming in. I wish I could give like rewards. When I like to teach, I like to give like in-person teaching. I love to give people like rewards. So if people don't want food, like I'll bring in for my students like cool, like either, well, back when erasers were something people used more frequently, like cool erasers in different shapes, or like, I don't know. I'm sorry, I can't throw you a cool, this is me throwing you a cool treat, my friend. Good job. Yes. Where the heck are the weights? That was the whole thing we learned about yesterday, right? Okay. High altitude Draco. If I gift a sub every time somebody got a question right, I would be so poor. But maybe once I get paid in like 10 days, we can consider that. Maybe for the latter half of the stream. Right now I'm broke as hell from Christmas shopping. But yeah, so where the heck are the weights in this? Because that's everything we learned yesterday, right? What is machine learning training? It's figuring out those weights, those coefficients. But we're missing them here. We're not missing them. Also, where's x? This isn't, I deliberately wrote this as not sigma of x, because x is hidden someplace else. In fact, this is t. And so really, if we wanna rewrite this with our weights, but it looks scarier, so oopsies, I just goofed it. Oh my god, enough with the t's, Jess. I just want everything to be t's. It's the physicist in me. Everything is a function of time. All right, there we go. Is this about the post being late again? Hi, paranoid Polaroid. No, it's not. But we have cooler math here. Thank you, Blomster Plukern, for following. It's quite a name. This is our beautiful logistic regression function for today. And like I said, nothing scary. This is the y equals mx plus b form. This is the, we're gonna write it with weights. Just like we had y equals mx plus b up here, and then we rewrote it with our betas, nothing scary. And also, if you remember from yesterday, we can expand this out to kind of be, you know, b naught plus, not b, beta x plus beta 2, x2, etc. for as long as however long our feature vector will be. So we can expand that out. And just like y equals mx plus b, where we said this is our intercept, this gives us our steepness. Here, since we don't really have an intercept in the strictest definition, it does eventually intercept, but that's less useful for us. This moves our curve to the right or to the left, and this gives us our steepness. So same kind of thing as before. I know it looks a lot scarier because suddenly there's like this weird e and there's a fraction, but it's not any more difficult, I promise. But what is more difficult are the weights and how we interpret them. And so to be able to talk about that, we're going to need a couple of concepts. We're going to need to step our way back and review a few things. And I've got way too much stuff in front of me. So, all right. Let me scroll down on my notes here. Okay. So there's another way that we can get to our logistic regression function. And this way, it's going to involve a little bit more math. So I'm going to tell you this. If you understood what we just went through and you're like, cool, yeah, right, you know, there's some scarier math, but like, it makes sense. I understand how we got our cool, 1/1 with some e's and some negatives, and you're like, yeah, I got this. Then don't worry about this part as much. But if you're interested in kind of diving into what this function is doing a little bit more, then this is for you. And is this logarithms? So hold, please. We'll get to why it's called logistic regression in a moment. Oh, thank you so much, Alda4, for subscribing. And yes, logistic regression. So one of the things that logistic regression does is it doesn't kind of make a forecast per se. So when we were talking yesterday about fitting linear regression lines to data, the best number of subs. Oh my god. Thank you, Love Phone. So I was saying I got distracted by the 69. All right. Right, fitting lines. I said that they could be used to kind of predict trends, make forecasts. In logistic regression, it's a little bit more complicated, and actually what we're predicting is the probability that something belongs to a class. Okay, and so for probability, that means that, oh my goodness, thank you so much, Onad. Thank you for the gift sub. And now RD1748, you are stuck with us. So welcome. Now you're a sub. You've got cool emotes. And when we do streams without the green screen, you can control all the lights for free. So welcome. Stuck forever, or at least for a month, which might feel like forever. Anyway. And so just a little bit of a review of some probability for folks that might not remember, right? The probability of something. And thank you, Adam00777700 for following. The probability of something, right, is the chance of that one outcome, that one event over all possible outcomes. That's not how you spell outcomes. Oh my lord, I'm sorry. This is like, I even specifically didn't take any cold medicine because I thought I'd be too loopy to stream, and now I'm kind of regretting it a little bit. Versus odds, by the way. Oh my god. Which you might hear like, when people talk about gambling, like 5-to-1 odds or something, right? Well, they're talking about one outcome versus all other outcomes. So, for example, we'll do a little example. Let me make sure I'm not covering this up. Okay, good. What is the probability of us rolling a 1 on a 6-sided die? Right? Well, one outcome, probably like there's one option here out of how many out of 6? Right? But the odds are actually 1 to 5. Exactly, Onad. 1 to 6 for probability, 1 to 5 for odds. What about an even dice roll? So if you're rolling in D&D around 0%, I know, right? I always roll like the nat 20s on things that are completely useless. And then when it comes time to finally, like, everyone's hurt and I'm trying to, like, attack the big enemy or something, then I'm real bad. But if we're looking at the probability of an even dice roll, for example, then we would have, right, 3 out of 6, which is just 1/2. But our odds are 3 to 3. I know this is confusing. I don't like odds. Probability makes me happy. That makes sense to me. Odds are annoying. You can also think of this, by the way, if we were to relate these to each other. Probability is just the odds over 1 plus the odds. And odds, similarly, are the probability over 1 minus the probability. And the reason why this is important is this should kind of start to look a little bit similar, right? This looks a little bit like our logistic regression function, just a smidge, right? Just you should kind of be thinking of that in your head. Well, I'm probably gonna have to give us more room here because I'm drawing everywhere. I also want to see, maybe for a future one, especially if I start using this Blackboard a lot more, I will think about saving them so that I can export them and maybe upload them to GitHub with the rest of the notes. Okay. And obviously, we need to write logistic regression at the top in the sparkly thing because I just really, really, really like this pen. All right. Okay, so logistic regression is about giving us the log odds of something being true or having our one outcome. So this is just like when we looked at our, oh my God, that's also probably covered up. Yep. Why is it all turned? Oh, because I literally have my hand turned. I'm sorry. Hold on, friends, I'll make it straight. So this is like, when I'm saying one here or true, we're talking about the population of data that is up here. I know, this music isn't bad, right? Thank you, very cool, for following. Okay, so what that means, right? Okay, so deep breath. Here we go, right? So recall what we just said. Our definition of odds was, right? Is probability 1 minus probability. Okay? So, you all ready for this? This is just this is the same thing as we had before. We just haven't simplified it yet. This is called, also, you'll hear it, you might hear it called your logit function. Okay, but we can clean this up, and spoiler alert, spoiler alert, we're gonna get to the same place we did before, all right? Which is, we can rearrange this into, oh my goodness, thank you, Sardini, for following, and thank you, oh no, shoot, you have a name that's dark blue on my thing. NK is PM. Thank you so much. I really, I love teaching. I've done a fair amount of it. I don't do it for a job anymore, but that doesn't mean I still love it. Okay, so now we're gonna rearrange this a little bit. Thank you, Fumbling to Glory, for following. Okay, so if we rearrange this, okay, I can do this. No cold medicine for me. I'm just glad I don't have that like super stuffed up like nasal sound yet, so I can still kind of sound normal for a little bit longer. No, all bets are off for some of our streams later this week. All right, so if we plug in and we rearrange a little bit, we can get plus 1x over 1 plus e to the x. Okay. And we simplify this just a little bit longer and just a little bit more, and you're going to get same thing we just saw earlier. Okay, so no, I'm not doing any French right now. So I've had some requests to have like a 5 minutes in French kind of thing, but I don't trust my French. I don't think it's good enough for me to have that be a reward that I would inflict on anyone at least until I have time to refresh my French a little bit. Hydrate. Oh, Ned. Hydrating today is a little bit less fun. I'm hydrating with tea. But I will hydrate. Okay, user 129835 say, hey, how's it going? What are we doing? We are working on logistic regression today. Okay, so again, this was just another way of showing you how to get to the same equation. But if the other way made sense to you, do not panic, okay? Like, whichever way works for you, whichever way kind of fits in your mind, go with that. The important thing, though, to understand here is that what we are going to get from our logistic regression function is going to be the log odds. That's going to be where we start. And we can kind of tease out of that the probability, because we know now how to get, from odds to probability. But the way that this logistic regression function started is as log odds. And that's also where we get logistic from. So if people looked at that equation and maybe like it wasn't immediately obvious to you where the log came in, now you know. And so that's why I wanted to kind of go through it a little bit more. But the important thing to really know is that we have that beautiful S-shaped sigmoid function that we get from this. Our possible outcomes are 0 or 1. And we can take those probabilities that we get, and from those probabilities, we can get, a prediction of whether or not something belongs to a class. But I'm giving away like a bit of the cool stuff here, but it also means, though, since we have a probability, right? Let me ask you this. What if I said, my classes for this are going to be cat or dog, and I show you a picture, and I'm telling you it's about the probability. If it's 60% probable that it's a dog, is it a dog? If it's 70% probable, is it a dog? Where do we draw that line? And that's one thing that is super, super, super cool about logistic regression. It gives you, I'm gonna turn this down just a smidge. I can't talk over music. I'm very bad at it, sorry. But it gives us the power to define that threshold for ourselves. So we can say, I want a slightly more flexible, looser function, so I'm gonna set my threshold at 60%. So once the probability of something being a yes, a dog, whatever, is above 60%, then assign it that class. And so that's gonna be one of the cool things that we'll be able to do with logistic regression. Okay, so let's put aside our tablet for now, and let's start working with our data a little bit. Okie dokie. Move this down. All right. So, and I'm going to have to zoom in probably again. So let me just get our imports. Oh, this doesn't feel weird. There we go. Pandas. Okay. And let me zoom in. Let's see. No, that's too big. No, stop. It won't stop. Please. How does that look? I forget exactly what percentage we had it at yesterday that you all enjoyed. Okay. So our data for today is going to be something called the Titanic dataset. And it's exactly what it sounds like. A bit bigger? All right. Oh my God, stop. There we go. How is that? 150. So somebody remember that, probably Loafbone. There we go. Oh my gosh. I forgot my equals. All right. So like I said, Milia, I feel like that's something, there's gotta be some cool way to give them bindings. But then again, there's all these shortcuts for Jupyter Notebooks themselves, but I wonder if you could like rebind it. I haven't messed with it myself, honestly. Just move tablet a little bit out of the way. Okay. So like I said, we're dealing with the Titanic dataset. This is a really, really famous dataset for machine learning and for data science, and it's exactly what it sounds like. We're going to be looking at, can you all still see that? Yeah, okay. This is a dataset of the passengers in the Titanic. And so we got a whole bunch of interesting information here. Passenger ID, which that's like an index, a little bit less important. Whether or not they survived, what their class was. So I think there was like first class, second class, and third class. Their name, their sex, their age. This is their number of siblings or spouses that they had aboard. So this poor person, Mr. Owen Harris, age 22, came aboard with a sibling or a spouse, and he did not survive. Is this legal? Is what legal? Parch is parents, so the number of parents that they had aboard. Ticket is their ticket number. Fare is the cost of their fare. Their cabin number if they had it, and what port they embarked at. And so a couple of things, unlike the data set that we worked with yesterday, so it's historical information, ONAD. So especially given that it was over 100 years ago, right? Yeah, 1918, 1917? Okay, it was in the 19-teens, I believe. And it's such an important historical event. Yes. I feel like it would be a little bit different if the tragedy happened like this year or something. But even then, I mean, there's lists of people who died from COVID. So, they're coming for you. I'm sorry, if you survived the Titanic and you're in my stream right now and upset at your name being part of this, let me know. I will remove you from this. Okay, I was very close, Nairo. It's the 19 preteens. Close enough, right? Okay. So, like I said, though, this data is going to be a little bit more finicky than what we dealt with yesterday, because as you can see, it's not all numeric. It's not like super, super cleaned. We have some nans, right? So let's take a little bit of a closer look at what we're dealing with. Leo DiCaprio about to pop up in chat. Okay, so actually, when I was looking up like the best version of this data to use for stream, I saw somebody doing a trying to say something about like Leo's chances of surviving the Titanic based on actually we can do that. We can make a Leo DiCaprio entry here and run our model on it to give us his probability of surviving. I don't remember what that person concluded. But we'll do it. All right, if you remember. So I'll need he was third class. His age in the movie, I don't remember. I don't think he had any siblings aboard. I don't know if Rose counts as a spouse. They weren't married. His parents definitely weren't. He had like a cousin, I think. And we don't know how much he paid for a fare. But we'll do our best. We'll figure it out. Okay. So, first thing that I really notice here is this is our label, right? We want to predict if people are going to. Didn't he get onto it for free? Did he? Were they sneaking aboard? I don't remember. It's been a long time since I've seen Titanic. But so survived is our target. So given that the rest of these, like it looks like there's a lot of data where we don't know whether they survived or not. So we're going to have to filter some of that out. Yeah, he won the tickets, but the tickets still were bought. Y'all are like Titanic experts here. What have I gotten myself into? But there's a couple of these columns that really are just not going to be, we can use our intuition to say this probably is not going to be helpful. Oh, Nairo, okay, you cheated. You saw it day before yesterday. Man, you were just studying for this for this stream. And so there's a couple of things that we can drop here. So namely passenger ID, because that's just another index. We already have an index. Thank you so much, Petro Corey, for following. Wait, Lofone, you haven't seen Titanic? Oh, well, that was probably too racy for your parents to let you as a young lad. Name, like, sorry, passengers, we don't care what your name really is. The ticket number, because that doesn't really matter, and their cabin number. Because the information that possibly might be encoded into ticket and cabin would be their class, and that's something we already have. Wait, Lowfoot, is that a real story? He said, I asked my parents if I could watch it, and they made me read a book on the real story and write a report instead. Oh my god. Oh, I don't know why that cracks me up. That's hysterical. All right. So now that we've got some of these sort of extraneous columns out of the way, let's also drop our nans. Okay, and now let's take a look at our data again. Not bad. All right. You do know, Lowphone, that was where the meme "Draw me like one of your French girls" comes from, right? I don't know, like sometimes sometimes Lowphone's lack of cultural awareness it can be shocking. Oh, you figured it out. All right, good. Okay. So we've got our data now, but we still have some problems. What kind of problems do we have? Tell me about it, chat. What are the problems? I'm mostly doing this to buy my time to drink hot tea. Exactly. Strawberry Jesus is right. Did you actually write the book report? Now I'm kind of curious. I want to read your book, your cranky teenage book report on Titanic. I wonder if your mom still has that. That'd be hysterical. Anyway, so it was actually quite interesting. Oh, poor. How old were you? Because like if you were like 10 or 11, I could see kind of being like, ooh, I don't know if this is appropriate, but please tell me you were like 16, because if so, that's hysterical. Okay, so some of the problems that we have here, the biggest one is that we have both in the sex and in embarked, we have strings, right? And we really need everything to be numbers. So what we're going to do is we're going to do something called, you might hear it called one-hot encoding or just getting dummy variables. And so what we're going to do is instead of having one column that is sex, we're going to have a column that is male, a column that is female, and it'll have a 1 or a 0 in it based on which category that particular entry belongs to. And thanks to pandas, we have get dummies. What is embarked? Embarked is what port they came in on. So I debated taking this out, of the data or leaving it in. But just for shits and giggles, I decided to leave it in. Let me see if I have notes on. Yes. I just wrote down port of embarkation as that. So it's like, I don't remember what the S and C stood for, but different ports where people could get on the ship. You were like 15? Okay, all right. So you could, thank you so much, Subertus123, for following. Absolutely, NKL, you could do that. Let let me see. We can actually do that anyway because there's a way to, I think the reason why I did it this way, I have an idea, hold on. So what we're gonna do this time is, there you go. So now it's 0 if male, 1 if female. And so you can you can do that. And there's a way, I don't know if it's get dummies. There's another method in pandas that you can do the one-hot encoding where it drops one of the columns. Because if you think about it, the letters, even in embarked, we've got embarked C, Q, and S. Well, if it's not C and it's not Q, it has to be S. So a lot of times you're able to drop one of those variables when you're doing this kind of encoding. You don't need both of them, especially not if it's completely binary, because then you can have just one column represent. So in any case, the other thing we need to take a look at is survived is the thing that we're looking to predict, right? So one of the things that can affect models quite a bit is something called class imbalance. And we have quite a bit of it here. So we have about twice as many cases in our data of somebody dying as someone surviving, which means we don't have balanced cases. So our models probably, if I'm going to hazard a guess from the start, it's more likely to probably be better at predicting deaths than predicting survival. We could map, no. So Strawberry Jesus, what you're suggesting is a common thing that people do. They're like, why not just map it to 1, 2, and 3? But you run into a problem here, which is like, think about this, right? If I have 1, 2, and 3 for C, Q, and S, what that's telling the model is somehow S has more of a value than C. It has a greater value. And you run very quickly into a problem there that doesn't accurately represent the category. So you can get away with that sometimes if like, if maybe there's kind of a value to what you're encoding. So maybe if I had a morning, afternoon, night, and those are my 3, you could make an argument for why you might have 1, 2, and 3, and that could be okay because it's maybe like there the value is more mapping to how much time has passed in the day. So it makes sense that night would have a higher value than morning. Here though, especially without kind of maybe knowing more about these ports, there's nothing they don't have a sequential relationship. So Josh Woods 2002, thank you for following. Because they don't have any kind of sequential relationship, it would be a mistake to encode them as 1, 2, and 3. And you said, can't you have a char category though? What do you mean? Can't you have a character category? Some kind of heuristic for confidence. Confidence in what? In any case, so what I was saying about class imbalance is this is gonna cause an issue for our model because it's gonna be a lot harder for our model to learn what kinds of features lead to surviving because we have half as many examples of it. So that'll be something for us to keep in mind. And that's gonna be our Y. That's what we're looking to predict here. And then our X is just everything else. Like a category embarked, which can be C, Q, or S. So yes, there are numbers too in the end, but again, you have to think about what are those values actually telling your model? And so, P class, it makes sense that you have 1, 2, and 3 for your, I guess, what is that called? Like your ticket class, because there actually is a value relationship between those things. Same thing with siblings or with the amount of parents or something, or even with gender. But there isn't that kind of sequential relationship or that value relationship between these various ports. And so if these were, what you would get there, Jan, is you'd be having your model associate the value of the letter C with this port, which is not at all a relationship that we actually want to encode into our model, because that's a coincidence. It could be the port Charleston, or it could be, I don't know, another port. Crap, someone help me. It could be like, Annapolis, but it doesn't mean that Annapolis being A has somehow a lesser value than Charleston. Like, you have to think very, very conscientiously about what kind of information you're giving your model when you do these kinds of encodings. And so in this case, the easiest way, and also the way that leads to the least amount of assumptions being made, is to just give them binary categories. No, I'm not going to lose my voice this early. Okay. So, let's pull in some stuff to start building our models. And also, Strawberry Jesus, you say category embarked, which can be CQRS. So when you are building a mathematical model, you can't use characters. And so you have to use integers or floats. I've kind of explained why you can't just use like C, turn it into hex or something and into like a number. So this is why, one, we need the kind of like, think about trying our y equals mx plus b. You can't plug in a C into y equals mx plus b and get a value for y. So, if that makes sense. I'm just going to copy some of these imports so I don't have to type all this out. A lot of this will look similar from what we did yesterday. Now, this I thought was really interesting, is something that I saw on a lot of websites and in a lot of like intro to data science materials for people learning machine learning, is something that I think honestly is not fully true, which is that I've seen several different places claiming that you don't need to scale your data when you're doing logistic regression. That is absolutely not true. You need to still scale your data. So I don't know if those are suddenly fighting words, but you do. Don't. There's a lot of misinformation, honestly, that's out there. And so we're gonna be good. We're gonna be good machine learning developers, and we're gonna scale our data. And we're gonna do exactly what we did yesterday. Goofy Lagrangian. So there are different ways to scale your data, but essentially, if we're looking here, it could be that the gender matters a lot more, and there's a greater difference between male and female in terms of our model than there is between the ages of 22 and 50. But numerically speaking, there's a much greater difference between 22 and 50 and then 0 and 1. So by scaling your data, you're kind of putting your data all on the same level, numerically speaking, so that the model doesn't kind of get skewed by values that seem high or low, but aren't really expressing the relationship of those values. Hopefully that makes sense. We covered a little bit of it tomorrow too, so if you want to watch the VOD from yesterday, I go into a little bit more of the math of how this particular scalar scales our feature vector. And I am coding in Python. All right, so we're going to do what we did yesterday, which is we're going to do our really, really basic out of the box. We're not going to mess with it. We're not going to change anything. Oh, wow, look at that. Look how great that is. Come on, someone from yesterday, speak up. Why can't we trust this number? Why should we be suspicious of this number? Why is this too good to be true? Hopefully somebody remembers. It's only been a day. Because I can't tell you how many times I've seen people do exactly like these lines of code with a model or a neural net and just be like, yeah, cool. See how great my model is? And I'm like, yes, Goofy Lagrangian. So it is normalized. So we scaled our data. We have normalized it. I didn't fool you. I just did the same steps we started out with yesterday, which was let's take our out-of-the-box scikit-learn logistic regression class. Let's fit our data to it. Shuffled, exactly. So both Strawberry Jesus and Goofy Lagrangian have it. Good job. So for a couple of reasons, we have one, we're not cross-validating this at all. We're just literally taking, the other thing, we've fit it on the entirety of our data. So we don't have any kind of test train split. We haven't cross-validated, so we haven't chosen different groups and tested on it to really make sure we're getting like the best, most, the best indication of our performance. And then also we haven't shuffled our data, which is really, really important, especially in like manifestos or manifests, right? Any kind of list of things that could possibly be in an order that is meaningful. You need to shuffle that shit. And is standardization required for logistic regression? It is. Shuffling is just what it sounds like, Onad. You mix it all up. So instead of having like data point 1, then data point 2, then data point 3, you mix up the order of the data. Okay. So we're gonna do a couple of things here. First of all, let's split our data. Thank you. Oh man, I don't know Spanish. That looks very Spanish. Casa is house, right? So I'll just call you Casa. Also reminds me of Casa, the astronomy software used to reduce radio data. Oh gosh, I always mix them. Split X, Y, and then let's give ourselves a random state. I always use 322 because that's my birthday. Okay, so we're gonna do a couple other things here. Actually give me un momento. I have something to sort out on stream. Hold on, friends. Just take a look at that awesome score. Think about it for a second while I mess with something. And that is... Okay, so hold on. I want to also import... Got this. Shuffle split. And then we're going to have our CV here be... And we'll use our same random state. Okay. Cool. And then, alrighty. Did I fix it? Is stream fixed? Okay, yes. All right, sorry. Married with children, is that what that means? Oh, that's awesome. Well, welcome. Conjios. Okay, so Casado's married. I'm like sort of basing this off like some tentative French here, but oh, that's really sweet. That's a very nice name. Oh, someone super romantic is coming to the chat. Oh, did I not? Did I split? Oh, I didn't rerun this. No. Splits with an S. There we go. All right. So all of this should look a little bit familiar from yesterday. And then we're gonna do, and then same random state. So we're doing that cross-validation that we did yesterday with our like ridge regression. Hang on, I think I goofed this. There we go. No. Number of generations reached. I'm gonna go back through this, hold on. Why are you grumpy at me? Oh, that's interesting. Let me go through my X and Y real quick. I went through the code literally right before stream and it worked. So, I know, you're grumpy, it's okay. You don't need to be grumpy with me anymore. Oh, okay. Little dearest. I did scale my data, right? Aha! here is oh, thank you so much, foi.dev, for the raid. Thank you. So this, my friends, here was my goof. I used the unscaled feature vector. Tell me again that you don't have to scale shit with logistic regression. I promise you, you do. Because guess what? It's gonna fit now. Yeah. So I promise you, don't listen. Always scale your feature vector, or you don't get convergence. Well, hi. I keep wanting to say froid because like the first part of your name looks like the French word for cold, but welcome Freud.dev. If I'm going to Americanize that a little bit. And thank you for following. X here is our feature vector. So that is going to be everything but survived. So that's our class of ticket, age, the number of siblings, the number of parents, the fare cost, the sex, and where the person embarked. So Y is whether or not they survived. That's what we're looking to predict. And so the mistake that I made here was a typo, and capital X is different. And if you remember from yesterday, I told you that was kind of like, I do this for a reason, is that if it's capitalized, I know I've scaled it. So I can very, very quickly skim through, and immediately I saw this was the lowercase x, and I knew I was using the unscaled data. That's like a shorthand that I use for myself, at least, just to be able to tell, okay, yes, I did the thing I thought it was. And CV stands for cross-validation. Okay, so let's get a better idea here then of how our model is performing. Okay, so not actually as bad. We're not getting the giant jump down that we got yesterday, but also because we did a little bit more of our best practices here. So curriculum vitae new. All right, so, oh no, I didn't mean to change it. I'll keep it large, hold on. Go back, okay. So we can also look at our coefficients. And so these are our weights, right? Okay, and you might say, cool, just like linear regression, right? We've extracted our awesome weights, done for the day. Unfortunately, not quite. It's a little bit more complicated. And so they're not as easy to interpret, unfortunately, as linear regression weights. And there's a couple reasons why. Remember that what we're aiming to get out of this is the log odds. So what we could do is we could get our intercept from, I think it's just intercept. Is that it? Yes, I did remember. We can get our intercept, we have our coefficient, we can plug in and get the odds based on that particular input. But it's a little bit different. It's not quite equal to the weights that we were talking about previously. But like I said earlier, one of the benefits is that we can use this to make actual predictions and get a probability of something. And we can also change that probability threshold based on how strict we want our model to be. Thank you so much for following Jippercorm. I'm gonna have to get more tea in a second. Okay, because that's keeping me going. I'm running on tea today entirely. Okay. So there's some pros and there's some cons to logistic regression. One of the pros is that, like I just mentioned, you're really able to kind of tweak the model. We can make it as strict or as flexible as we really want. Don't listen to people who say your features don't need scaling. That is bullshit. You need to always scale your features. And also it gives us the wonderful output of probabilities. However, it can be a little bit slow sometimes, but it is a simpler, lighter weight model. And while we don't have quite the obvious linear relationship that we had before, it still is going to assume a linear relationship between the log odds and the feature vector. So the difference here being, if you remember our XY graph, instead of having X and Y here, we have log odds and X. And so there is still an assumption under the hood of a linear relationship. So if that's not true, then this model is going to suffer. And thank you, Ludo Milo, for following. And don't forget to add honey. I know, actually, give me uno momento here. Just move this. Okay, put some vodka in there. Yeah, no. All right. Even with 3 monitors, that is not enough for streaming. I'm learning this the hard way. There's too many windows I have to have open. Okay. Or hot sauce. Well, you know what? Postal Service is failing me a little bit because Strophium's Amazing Hot Sauce was supposed to arrive, and I was planning on just pretty much eating it on everything. And it's been a little bit delayed thanks to, I think, the holidays and everything. So as soon as that arrives, though, I'm sure my sinuses will feel much, much, much better. Yeah, USPS is always slammed around this time of year. Okay. Oh, no, our music stopped. I literally just... Hold on. I had it on to continue. Oh, no, that's the shuffle button. Or the... There we go. Now it's on a loop. Wait, maybe it'll play the same song over and over. We don't want that either. Suddenly everyone starts fleeing. Okay, I think just one click will do. Okay. So... Oh, right. Okay. I remember what I wanted to talk about next is we're going to talk about some metrics and how to interpret your machine learning models. What is intercept? So think back to your y equals mx plus b, right? This is kind of the intercept for the function. You've been trying to ship a package to Denmark for 6 weeks? Yikes. Okay. So first, let's kind of do what we did before, where we're going to have our predictions and then the true outcomes, and then we can compare them. So we're going to have it predict. Did I import Seaborn? Do I need Seaborn? I do. There we go. Test ypred. And then what else do I need? I need to annotate this. And then predicted. Let me see, I wrote it down so I always get this stuff confused. See, I wrote it down so I wouldn't get it confused. The predicted died came first. Predicted survived. All right, so this, my friend, you never got around to using Seaborn. I love Seaborn. I love Matplotlib too, but I really love Seaborn. Why did no one bring Masatosaurus and Apple? I know. This happens every winter, that there's going to be some part of the winter where it just starts, like, I don't know. I have a really crappy immune system, so that's part of it. But this, my friends, is called a confusion matrix. And no, it's not designed to confuse you. This is measuring how the performance of a classification model. And I know, right? It's understandable if right now you're like, wait. We're doing regression. Tomorrow you said we'd be doing classification. What gives? Well, this is the joy and the wonder, is that logistic regression is a classification model. I know. Anything that tries to classify things into categorical groups is a classification model. And so even if it's just a binary regression like this, it is technically a classification model. And you say, are you making these functions or are they built in? So what functions are you talking about? Most of the stuff we're using here are built in. So this is built into scikit-learn's metrics module, and we're using the confusion matrix method. And I mean, you could technically like build this yourself if you wanted to, but you know, why do that when it's built in? So what you're looking at here is you're looking at the number of predictions where up here we have what we might say are our true negatives. Okay, so this is people who actually died and we predicted, and our model predicted they die. And then down here, we have what we would call our true positives. People where we predicted they survived and they actually did survive. And then over here, we have our false positives, because we predicted they survived and they died. And over here, we have our false negatives. We predicted they died when they actually did survive. So this is a great way of breaking things down so you can immediately see where the strengths of your model is. Yay, more tea. Okay. I love tea, and I love really hot tea. Like I burned my tongue and my mouth so many times on tea, and it's entirely worth it. It's just like so comforting. Okay. And as we predicted right at the start, when we were looking at our class imbalance, right? Remember what I said? I said hunch being this model's probably going to do better at predicting deaths than predicting survival because of our class imbalance. And that's exactly what we're seeing, is that our model's far better at predicting true negatives than it is at predicting true positives. But you might be asking, oh, like, you know, true positives, true negatives, like who cares, right? Well, this is actually a really, really, really interesting aspect of machine learning. At least I find it interesting. A lot of people, they start to like snooze when you talk about metrics, but this is really important because not every model's the same. Not every problem is the same. And there are going to be cases where you care far, far, far more about the ability of your model to predict true positives than you are about your model's ability to predict true negatives. And so that kind of distinction matters. And we even have words to describe that in machine learning. And so if you will bear with me briefly, we're going to go back to our Blackboard for a second. And levy.exe, welcome. That's not the right thing. That is the right thing. All right. So let's just move things around here. Give me a second. Find my stylus. Find my tablet. T-bot. I need a copy bot. I've seen a lot of people doing stuff that'll work with like Alexa, and I have some of the like home automation stuff. So I would love to have a coffee bot where I could just from bed be like, yo, start the coffee, please. That would be awesome. Okay. And thank you for following Kev303. All right. Okay. So now we're not talking about logistic regression specifically. These terms, and I would say learn them now, try to get used to using them now, because when we start to evaluate how our neural nets are performing, these are things that we're going to be considering. And if you're interested in, working in machine learning or working in data science, these are terms that are used quite a lot. So we're going to be talking about our metrics. How do we measure the performance of our models? Okay, and so we just talked about a confusion matrix, right? And so that kind of looked like this, right? I'll use red because that'll make sense. We have true negatives, and then we have our true positives. And then here we have our false negatives and our false positives. Okay. And so I think it's kind of intuitive to understand a true negative and true positive, right? Where we predicted yes, the answer was yes. Here we predicted no, the answer was no, and here's where we screwed it up. Confusion matrix sounds like something out of Star Trek. I know, right? So I remember way back when I was first learning machine learning stuff, like I hadn't been doing it very long, and I was listening to some other, more senior developers talking about their classification model. And at the time, I had only really worked with linear regression and a couple other kinds of models, unsupervised learning. And like, what's the confusion matrix? And it sounded like Star Trek to me at the time. Like little baby me was just like, the fuck is a confusion matrix? So I remember like scribbling it down in my notebook, like, you've got to look this up. Okay, you got to understand what this is. And I looked up, I was like, oh, that's really straightforward, but okay. All right. So we might be interested in different ways of evaluating our model. And we're going to go through some examples later, but try to think of some kind of on your own here. So one measurement that, of course, I think we're all familiar with is accuracy, right? And so, but if we were to define accuracy in terms of these terms now, right? Our accuracy here is going to be the times we got it right, our true positives and our true negatives over everything, over the total, right? So if we were to go back to our model from before, let me actually just peek at, where is it? Here it is. So we've got 85 and 51 over 42. So our accuracy here, 85 plus what, 40 over 42. Shit, what's the second number? Oh, Lord, I'm 85 and 51. Okay, 85 and 51 over 42. If somebody wants to do math there for me while I sneeze, 136 over 42 is like, I'm too stuffed up. It's fine. 136 over 42 that's not right. Well, we would want to swap it. So 42 over 136 gives us 31%. No, wait, I didn't add that right, did I? It would be over all of them. Oh my God, I just wrote 42 because I'm a dork face. I was trying to remember the 21. Yay! All right, so this would be over 42 plus 136, which would be 136 over 178. Thank you, friends. Exactly. You're all like jumped at like, what is she doing? It's like, oh no. Soon I'm not even going to be speaking English, and then you all are going to be like, what's happening? I don't understand anything. And so that gives us an accuracy of about 76.4%. All right. But this is just one way. That's not a straight line. Lord Almighty. Better. This is just one way that we can measure performance, because there might be cases where we're not even really concerned about the accuracy of our model. We're concerned about something else. And so we've got a couple other ways to talk about this, and we'll learn a couple of different terms here. But one thing we can think about is not written like that. And let's change colors. Let's make this exciting. All right. We might be concerned with our true positive rate. TPR, which is exactly what it sounds like, which is that is your number of true positives over all the positives, I believe. True positives over all of them, right? No. Over all of the positives. Yes. So after all our guesses of positives, so TP plus our false positives. And similarly, we might be interested in our false positive rate. FPR, which is the amount of false positives we've given. So the times that we said something was yes when the answer was no. Oh, hi, Matt. Yay. Hi, yeah, thank you. Isn't it a nice green screen? Chat help me save up for it. Plus the true negatives plus our false positives. And so you might be kind of wondering to yourself, well, why would we care about one versus the other? Isn't accuracy always, always, always what we're concerned with? It isn't. And so one of the examples that I wrote down, because this is a really good example to use, and I'll also hold on really quick. So of all true positives and false positives. So there's also, let me give you two other terms here actually that will be very helpful before we move on. One is recall, right? And this is the in our particular case, this would be of all actual survivals, what percent did we label correctly? So this has less to do with like the true negatives, false positives, false negatives, and this has to do more, this is kind of like from a data perspective. So of all of the people that actually survived, what percent did we label correctly? And then you'll hear this contrasted with precision, which is of all these survivals or survivors, whatever, our model predicted, what percent actually survived? So what percent did we get right? And so I think that one, you might hear the precision recall function or looking at the precision recall curve, and we're going to look at it for our model, and I'll explain why these are important. But first, think about if we were to focus only on recall here. So of all the actual survivals, what percentage did we label correctly? We focused our model, our tuning, everything on maximizing our recall. We would end up having, a really flexible model. It means we might have more mislabels when it comes to mislabeling deaths as survivals, but we're more likely to get all of the survivals in there. So if that's what we care about, we don't care if sometimes we have some false positives. All we really care about is getting as many, we have to label all of those positives, but we don't care kind of what gets caught in the net. Then we would want to maximize recall. Maximizing precision, however, is kind of the opposite. So we have a really strict model if we maximize precision, but it means that we can kind of trust the labels a little bit more. So we know if we maximize precision that when our model says someone survived, they probably survived. But it comes at the expense of maybe some of the survivors accidentally getting labeled as deceased. And so how is recall different from true positive rate? Of all actual survivals. So here's the funny thing is that I almost never use TPR and FPR. Almost always what I see used is recall and precision. And so the difference here is this includes false positives. So what we're talking about here is of all, in the data, of all survivals, of all positives, what one did we label correctly? So this is a little bit different because here our true positive rate is of all things our model labeled positive, how many were true? This says of all actual survivals in the data, what percentage did we label correctly? So it's a slight distinction. I will say that I usually use recall and precision, but these do come up, so it's important to kind of at least know what they're talking about. Sorry, I should put that's what that is. So is there those of you who don't know this, because if you have, you probably have heard the examples already of recall versus precision. And thank you so much, Dat Deets, for following. But can you think of examples why we might want to maximize, let's say, maximize recall? So that would be, again, that's our looser, more flexible model where we're casting a wider net. You can think of it like that. We have a greater chance of catching all of the positives, but we run the risk of mislabeling the negatives. So our false positive rate is going to be higher with a very, very, very high recall model. So that might be, oh no, I dropped my stylus. Hold on. Think of like a real world example though, like you're building a machine learning model for someone. Why might we be interested in maximizing recall? So this is gonna increase our false positive rate, but it's also going to increase our, well, it's gonna also, hold on one second. Alex Saku, thank you so much for following. COVID testing, that's a really, really good, that's an excellent example. So with COVID testing, the classical example that you'll hear done in machine learning classes, and thank you, Darren, for following, will be medical imaging, so diagnosing cancer from medical images. There we want a really, really high recall. We don't care if, like, the consequence of falsely labeling somebody as having cancer or having COVID when they don't, the ramifications of that are far lower than accidentally saying somebody is negative when they're positive. So that would be a perfect example of a case in which we would want very, very high recall in our model, because we don't care sometimes if we accidentally give somebody a positive when really they're negative. We care most about getting all of the positives. What about precision? When would we almost care about the opposite, where we don't mind missing some of the positives as long as we know when it's positive, like we extra trust it? Would using this model be used only to mass check, then go into review if it's flagged? Well, generic crew, what you're talking about is something called human in the loop, which is something that you need for all machine learning models. I would say that almost always we should not have something making autonomous decisions when human lives or human health and well-being is kind of in the balance. So as much as possible, we should have a human in the loop. So our models should flag things and humans should review them. But still, what do you think would be an example of a model where we would have the opposite of like the COVID example, where we would want to maximize our precision? And Darren, what is your machine learning? Today we are learning logistic regression, and we're talking about metrics that are used to evaluate machine learning models. And I'm sorry, I'm losing my voice a little bit. Oh, it's far too early in the 12 days of machine learning miss to lose my voice. But here, if you're interested in learning more about what we're doing, finance for precision. Okay, can you give me an example? Are you thinking about, what kind of finance model are you thinking of? So I'll give you one of the examples that's often used in like textbooks and stuff is that of a spam filter. And so if you think about a spam filter, it's far, far more important that when we label something spam, it actually is spam than, accidentally letting some spam through, right? It's fine to let some spam through. It sucks, but it's far, like which matters more, right? The danger here is it would be far, far worse to label an important email spam than it would to let some spam go through. And so that's why a high precision model would be a spam filter. And you can also see, this is why performance with machine learning models is complicated, and it's not as simple as just accuracy. It really depends on your data and on your situation. And so as much as possible, I know so far when we've been kind of doing some of these models, I'm just like, okay, let's look at this score. Let's look at the accuracy, right? But what actually matters a lot more depends on our situation. So for our Titanic model, for example, thank you, La Fantasia, for following. We might care about recall. We might say, you know what? I don't mind if we get some of the, if we accidentally label some dead people as survived, but I want to make sure we label all the survivors. Or we might actually care being like, you know what? I don't care if we accidentally miss some survivors. I want to know that if I predict someone survived, they did. And then we would maximize precision. But Pony Creek, you say just tuning in, checking out different channels. Raid incoming. Oh Lord. Prepare yourselves. My channel is, tell me more about your channel. I'm like put on the spot. Well, right now, like I said, you can use the holiday command to learn about what we're doing on the channel right now. We're doing 12 days of machine learning miss. Normally my channel is a mix of astrophysics, data science, machine learning, programming, and some video games. So it's a little bit of a bunch of different things. Okay, gotta drink the hot tea before the raid, I guess, so that I don't lose my voice. But hopefully this makes sense a little bit. Oh my goodness, Ace Gikmo, welcome, and hi raiders. Thank you so much for raiding. And swearing, don't forget swearing. I've been very good with this. I haven't sworn too much. My teacher hat has been on, and so I've been swearing a lot less than when I play video games. But welcome raiders. Hi everyone. Hopefully you are as excited as we are for the 12 days of machine learning miss. Today we have built a logistic regression model to predict the survival chances of people on the Titanic. And we are right now learning all about metrics and the different ways that we can evaluate our machine learning models. It is a lot of people. And so they're coming in at a very interesting point when the geeky whiteboard is up, but you should all check out that really cool Galaxy pen that I use to write metrics because it's pretty dope. I'm also fighting a cold, so there's like lots and lots of slurping of tea, so I apologize, friends. Okay, the hot tea is helping. And lots of people are following. I will try to get to all of you. Oh my goodness. One Shield, Aglethe, Disley, Itsy Bitsy Spider, Alexandro Gotek, Andre Apolari, Maximum Occupancy, SportHack77. Thank you so much for following and welcome. We do need more Galaxy Pen. Here, I'll just be like, hi. Hi, Raiders. There you go. More Galaxy Pen. This is a 2C board. Thank you so much, Ace Gikmo. Let's give a shout out to Ace Gikmo, somebody in chat, please. Thank you so much for the raid. So as we were kind of talking about, right? This is like, we got to move beyond accuracy. If you're building some cool neural net, it's got to be more than just accuracy. What you're kind of concerned about is you're looking at your trade-off between recall and precision and which one matters more for your particular model. Raid train. Yay! And oh yes, okay, shout out to Lana Lux as well. I follow her. She has an awesome game development channel. And we do a bit of beginner game development on this channel. Very, very beginner. I am learning the basics of C# and Unity. But you should definitely check out Lana. She is doing amazing things with like a really cool survival game, I think. I'm sorry if I don't describe it well, but it looks really, really cool. So this is Ori Concept Arts. You ask, is this unsupervised machine learning? This here, we're starting out with supervised machine learning, actually. I will bring up really quick our schedule. So I know, sorry, brightness alert. So that's, I don't know how this works. How does it work on Windows? All right. In any case, you can see yesterday we did linear regression. Today we did logistic regression, which is a kind of classification, but tomorrow we'll be moving on to more classification. That'll be kind of wrapping up a lot of our, and then we'll do some ensembling with random forest. That'll be wrapping up our supervised machine learning. Then we'll move on to unsupervised machine learning. We'll do anomaly detection, some reinforcement learning, move into the wonderful world of neural nets. It's gonna be great. We're gonna have lots and lots of things to do. So, what's it called when you cross-validate models against each other? I think what you're thinking of is generative adversarial networks, or GANs. And so I wouldn't necessarily say you're cross-validating models against each other, but that's, I think, what you're talking about. No Skynet yet. Right now, all we did was we went through this wonderful Titanic dataset, which is a really, really popular dataset because it's very clean, easy to work with, great for beginners. Also available at Kaggle, by the way. So if you don't know what that is and you're into machine learning, they've got lots of cool data sets for you to use. Otherwise, we went through it, we cleaned it up, we had some fun, and I think the best score we really got was about 76% accuracy. And then we kind of sat down and we're like, hey, what's this whole accuracy thing mean? Do we actually care about accuracy, or based on this model, do we care about something else? And so that's why we brought back our wonderful blackboard and we started talking about true positive rate, false positive rate, recall, and precision. Because, all right. And the cold, and fighting my cold. Because really when you're dealing with a machine learning model, you have to go beyond just accuracy. Thank you so much for following. Oh, it looks like I missed some people. There was a lot of alerts. Snack Overflow. Yes, if you haven't seen Kelly Mahoney's stickers for Snack Overflow, you should check them out. OG Marathon. Something in Korean. I'm sorry, I can't read Korean. Just As Good Joe. Jabako. Morkback. And Suen Atra. Thank you so much for following. New coder. Well, if Lana wants to put some machine learning in her game, I would love to help. I actually have done some cool machine learning applied to video games, but not necessarily built into video games. Yes. Oh, stickers. Okay, hold on, Snack Overflow. I got you, friend. I got you. So Kelly Mahoney, Snack Overflow sticker. She has, I think it's Etsy. Okay, so it's So Splush is her Etsy. You should check it out. And she's got really, really cute Snack Overflow stickers and just very cute things in general. So you should definitely check it out. And yeah, Lana, I think AI in video games is very, very cool and something really interesting. There have been some really cool indie games that have come out that have utilized AI in very interesting ways. Oh my goodness, thank you, Corsi, for gifting a sub to Lana. Welcome, all of you. That is, oh my goodness, and you've gifted 5 rewards. Thank you, Corsi. That's very kind. There actually was a game. Oh, what is it called? Hello Neighbor, I think. And oh my goodness, thank you so much, Corsi and Serata Cyclist, for subscribing. You all are wonderful. Thank you so much. Welcome to the stream. It's, what do you call it? I think it's called Hello Neighbor, something neighbor. And it was a really, really cool application of AI in a video game where the whole point of the game is you're trying to break into your neighbor's house. And, but this is the interesting thing is eventually, you get caught and you're like, okay, cool. Like I remember like this window was unlocked, right? So you're like, oh my gosh, Loafbone and Corsi, you all. Thank you. Oh my goodness. Thank you so much. And you've started a hype train. You all are too wonderful. Thank you. Okay, apparently it is called Hello Neighbor. But so you get caught, whatever, and you restart and you think I've died, right? And in like that sort of gamer intuition that we all have, you think, 3rd tier gaming. Oh my goodness. Thank you. You all. Thank you so much. You are wonderful. Thank you, thank you, thank you, thank you 1,000,000% for the gift subs. And Corsi still gifting things. Thank you so much. Now you all are stuck with me and the stream. But so like I feel like every time, you die in a video game, right? And you start over, you think I've got a fresh start, right? So I think like one time I snuck into this guy's house through a window that was unlocked. I was like, already got this. Like, I know now. So I went back through. Ignorant me walks up to the same window. This time it's locked. So every time you break in, the AI that plays your neighbor learns from what you did and makes it harder. So you're constantly fighting against something that's learning from what you're doing too. Oh my gosh, Onad! Thank you so much for the gift sub. And it looks like Ballerberg 9005. You have a sub now. But yeah, so you should check it out. Hello Neighbor, indie game. It's not like the world's greatest graphics or anything, but I thought it was this really, really compelling use of machine learning. Oh my gosh! Corsi! Oh my goodness! Thank you! Holy crap! Thank you so much! And so many people. Also, Code Monkey Like You, excellent name, excellent song. Thank you so much. And level 5 hype train. I still don't really know what a hype train is, but I think it means emotes for all of you. So there you go. Thank you, thank you, thank you. That's a wonderful holiday gift. I appreciate it so much. And Corsi, oh my gosh. You are so wonderful. C Films and Nathaniel Bumpo and Peak 9117 and Sim DK. You all have subs now. I know, almost the New Year's Eve goal that I didn't think I'd even hit. So thank you, Corsi. Oh my goodness. Like feeling all like overwhelmed. I don't know what to do. Thank you so much. This is really a wonderful surprise. Thank you. The closed captions is going wild, I bet, because I don't even know what to say. Anyway, you all should check out the game, seriously. It was a cool application of AI. I thought it was interesting. It makes the game really, really challenging. Like, your neighbor's doing something funky. You're trying to find out what's going on in their house, and it's an AI that's learning from what you do. So I think it's a cheaper game. I know it's on Switch. You should check it out. I know, Corsi's awesome. Where is X? Yes, also, you should all check out Where is X's stream, by the way. I had so much fun watching them do some of the Advent of Code challenges, a language I didn't even know. I hadn't even heard of it, honestly, but it was really, really cool to watch somebody else tackling the Advent of Code challenges as well. So, I know, so close, look at this. Oh my goodness. I know, Canis. What is happening? so many subs. Oh my goodness. So thank you. That's kind of my reaction. I think my brain is in all caps right now. I don't even remember what we were working on. I was going to show you something else, I think. Because we did I was going to just briefly show you the precision recall curve for our model. But I got a little bit distracted by so many wonderful people. Oh my goodness. All right, so very briefly to show some of the wonderful, wonderful people who built this model with me. We're gonna take a look at our I can't even talk anymore. I'm just like too excited. We're gonna look at our precision recall curve. Main village. No, stay. Why are you leaving? And then X test and Y test. Yeah, I know. I finally got the closed captions working. I stopped being a complete dork. And thank you so much, Beta G0 for following. Welcome. Is that the blue switches? Yes, it is. Don't I have a keyboard command? I think I do. No? Yes, I do. There you go. So this is what the precision recall curve for our model looks like. And so the average we're looking at is about 0.81, but still you can see how it's going to be. Oh my gosh, Matthew, what are you doing? We've reached our goal and it isn't even close to New Year's Eve. Oh my gosh, thank you, Matt. Also, Reaper of Pages is my best friend, Matt, and Matt gifting subs to somebody that is called Only One Matt, I think is very excellent. But thank you so much. You all are so sweet. Now I'm kind of understanding why Alt F4 kind of like left stream one time, got really flustered with all of the subs. It's like you don't really know what to do. Oh my gosh, Foffy and Drop Bear getting gift subs from Reaper of Pages. Thank you, Matt. That's very sweet. Jeez, you all. Drink tea, cover up my awkwardness. Oh, yay, look at that. We got a level 5 hype train emote. I don't know what that is, but it's really dorky looking, and I kind of like it. So many emotes. Warzone, you're like, I'm dodging so many bullets. Hey, subbing to my stream is not getting hit with a bullet, my friend. You get some very, very cool, very, very cool perks. Well, one perk. I'll do this for you all. Would you all like to see my dogs? Let me see. This is my Furbo camera. Usually I only do this if people donate bits, but this one's free because everyone is so sweet and gave so many gift subs. So let's see if I can get my dogs to come over. So you kind of just pull that thing and it'll like make this like beep beep noise. Oh, you donated bits? Okay, yes, I see that. It's like behind on the alerts. There we go. Thank you, Onad. Let's see if we can get them to come over. Just like keep shooting out treats. Like, love me, please. Love me. Dogs, love me. Yep, I've got the feed up. 3rd tier, do not worry. Thank you so much, SimDK, for subscribing as well. And Diatoms, I know, right? Let's see if we can get them to come over. Oh. Hubble. This is Hubble. A very pixelated Hubble, but still a Hubble. He is super excited for all the treats. Oh, what a good boy. He is an excellent, excellent pup. So here's a little bit of a treat for all of the subs, all of you wonderful people. Thank you, Firewell, for following. He's still pretty in the pixels. Yeah, he is. He's a very, very, very good boy. Oh my goodness. I made him an excellent dinner, so if he doesn't seem super interested in treats, that's because I made this boy like a pound of meatballs that he got to eat. And he's probably still gonna eat the treats. Mr. Pickles? Who is Mr. Pickles? Also, yes, Hubble is our stream emote. You can see it on my mic as well. I know, I keep just giving him a lot of treats. So one of my favorite things that he's probably doing now is he has this toy that teaches him how to do sequences with lights. And so he uses his nose to press the lights in a certain order. They flash in a certain order, he has to press them back and it gives him a treat. So he thought that this Furbo worked in a similar way. So like the first time we got it, he was just mashing his face up against it, kind of hoping that if he hit it hard enough with his nose, it would give him treats. Which I thought was like both sad and also really cute. It's like, I'm sorry, Hubble, it doesn't work that way. Thank you so much for following King Von Edward. And let's see here. Bab75 and Snakebite for the bits. I guess it means we got to give him more treats. Wow. This poor dog. He can't gain weight, all right? Like, he's got some bad joints. He's a little bit like me, so we have to be careful with him. But it's Christmas. We can give him some extra treats. Oh, more treats. Okay. All right, Matt. Funny thing being that I've been giving him treats all day. Look at him. He's like, yes, please. Yes, please. I want to get it so he can start catching them. And Ian, Alex Hart. Okay, so that's 2 treats. 10 is probably sleeping. Let's see. I think we can probably use our 10 command. Looks like Tennessee's in a blanket. No, Hubble, where are you going? Come back, love us. Hubble's not the most affectionate dog, too, so this is also just a real life view of how I try to get him to love me. Is just lots and lots of treats. Love me, Hubble. Love me. Here you go. Even more. Ian Alex Hart wants more treats for you, and so does Matt. Okay. Here's another one. This poor dog is like, what the fuck is going on? Look at him. He's like, what is this thing doing? Tennessee, so I will tell you this. Tennessee sings at the end of stream. So I think it's you can get a little bit of a preview there, but usually we wrap up stream at the end of the night by having him sing to a sci-fi TV show theme. So if that is, you know, something you enjoy, stick around. Your cheer is so late. I know the poor alerts are like struggling a little bit. Thank you for following Prima3 and Arturo. Look at him. He's doing the thing with his nose. He's like, I will try this. I'm gonna try. Or he's like licking the outside. Is he chewing on it? Hubble, don't do that. Oh, let's see if I can make him do it. I'll see if I can make him sit. He hasn't done this so far. So I gotta pull up the app on my phone and see if I can make him sit for you. Pull up the app. So, Oh, I thought he was going to sit there for a second. Hold on. Let's see. All right. Hubble, sit. Hubble. Hubble, sit. Hubble, can you sit? You want a treat? Hubble, sit your butt. Yes, good boy. You get a treat. Good boy, Hubble. Good sit. Look at him looking back like, you done yelling at me now, Mom? Oh, what a good boy. That hesitation though, he was not wanting to do it. He can do lots of really cool tricks, but it's a struggle through the furbo because he doesn't see me, so he thinks he can get away with not doing anything. How long did it take for Tennessee to learn a song? Oh, he doesn't learn them. It's just like, it's from his soul. If we play a song he likes, he'll start singing, whether he knows it or not. He's usually like, he's a lot more confident if he knows it though. So he's a very good boy. But so let's see here. Okay, I can't tell with these alerts. They're still so far behind. So I'm like, do I have to give him more? He seems, okay, you can't be hungry. You see this? You see what he's doing here? Little sassy dog. He does this where, now wait for it. He's gonna start to look around. Yup. So he'll go and he'll like dramatically like lick his empty food bowl. Like, I'm so hungry. Feed me. I'm dying of hunger. So he'll just like look behind him at us or like walk around the house, come back, lick loudly his empty food bowl, then walk around some more. He had a giant dinner, I'll have you know. Don't believe him. Yeah, sometimes he gets so cross that he'll like get his nose under his food bowl and start flipping it if he's hungry and he wants more food. But he had a bunch of meatballs today. Like, I made him a really amazing dinner, so. Suanatra, I know. He doesn't, if he's had dinner, he's had a very good dinner, so he's not gonna get more food. What a little dork. Anyway, the last thing I really wanted to cover today was the precision recall curve. So we can go back to our just chatting. And if there are any kind of like leftover questions or folks want to talk a little bit about machine learning generally, I don't want to give away too much because we're going to be covering a lot of topics in this wonderful 12 days of machine learning miss, ML miss, whatever. But if you have some general questions or anything, I know the time flew by. And because I'm doing so many streams, I was trying to like limit myself to about 2 to 3 hours. So we ended a little bit early, even with distractions and wonderful raids. Thank you, Nomad Derek, for following. But so if there are some questions or people want to ask generally about data science, or, I mean, this isn't an astronomy stream, but I'm happy to answer space questions as well for just a little bit, and then we'll have Tennessee sing for you all, because he's a very good boy. What are you sending me? What is this link? Oh God, okay, maybe that's a way to get people to, some people to wear masks. And yep, so we are done with logistic regression. So talk about the merged galaxies reforming their spirals. Oh, yes. Okay, hold on. Let me pull up that image from Discord because that was from earlier. So let me find it. This was a beautiful, beautiful image I found. Here it is. Open original. And I guess we'll go back to this screen so you all can see. All right. So what we're looking at here, because from what I understood, that doesn't happen. So this is the interesting thing, right? Is like most galaxies that you see actually have experienced merger events. So they've collided with other galaxies during their lifetime, particularly because these kinds of events, thank you so much for following Programmer's Stream, are what drive matter inflow into the center of the galaxy. And that's what feeds the supermassive black hole at the center. So it's one of the most common ways to grow that central supermassive black hole that we all know and love. But this is really interesting because we often can see sort of collisions as they're happening. We can see collisions as they're in progress. But this is kind of a rare view into a post-collision state where the galaxy is starting to stabilize. And so it's interesting because we can kind of see that we've got maybe some spiral structure here starting again, and also the disk itself seems to be stabilizing as well. And so I thought it was beautiful, but also two, really, really cool because it's a little bit of a rare look into a in-progress reformation of, that sounds like reforming, whatever, of spiral structure. And let's see, am I a memer? I don't even know what that is. How did I get into astrophysics? So my background actually wasn't in astrophysics. I went to undergrad for North African linguistics, switched into astrophysics, went to grad school for that, switched out again and started doing machine learning development, machine learning engineering, whatever. I don't know, like who wouldn't be into astronomy and astrophysics? Like, look at that. How can you see beautiful pictures of galaxies and learn about the physics of black holes and not just kind of fall in love, right? So at least for me, I think the night sky and especially distant galaxies are always going to kind of like tug at me a little bit. Academia is a rough place though. So, just as good, Joe, you say, I have a question. What are some metrics you would use to compare unsupervised results? Some we don't have ground truth labels and can't compute accuracy. Ooh. That's a really good question. And we'll be covering some of it when we start unsupervised learning, so I don't want to give too much away. That said, a lot of times it depends on what kind of unsupervised learning you're doing, but one of the things that I've seen a lot of times is that people will they'll build supervised learning models on a smaller subset of data with the intention of creating like an unsupervised learning model later. So you can get some, or they'll have some labels. So you'll have like what's called semi-supervised learning. But you're absolutely right. It's a lot harder. And so that comes back to something I was talking about earlier, which is the importance of having a human in the loop. And so I've seen this with some cybersecurity models, for example, where you don't really have labels. So it's really hard to kind of train on. And so instead what you're looking at, you can't like predict a class, for example, if you don't have class labels to work from, but you can measure something else about the data. So you can use something like clustering to measure how anomalous that data is. Does it not fit in with the normal groups of data that you have? And so for that, you don't really need a label because what you're measuring is like a physical quantity of like anomalousness. And that's something we actually are going to have a whole session on anomaly detection. But then, in my opinion, the best way forward would be to pass some of those examples off to a human that would then review them, provide labels of like, yes, computer, you did a good job. No, computer, you were wrong. And then you can also have the algorithm learn from that as well. So it starts out unsupervised, but then as you start to get that human in the loop feedback, it becomes semi-supervised learning. Hopefully that helps, but also stick around because we'll be talking more about unsupervised learning day after tomorrow, so I think. And he said, I wanted to be an astrophysicist, but my particle physicist advisor convinced me to be an engineer. I remember in some of my physics classes in grad school, I kept like getting talked down to by my professors because they'd be like, you think too much like an engineer. And I'm like, I don't think that's a bad thing. Like, that sounds like a good thing. I don't mind that whatsoever. And actually, in one of my graduate astrophysics classes, we ended up building a telescope. And so that was really cool, really hard, really cool. But I think thinking like an engineer kind of came in handy then. And King Von Edward, you say, how do you switch from linguistics to astrophysics? You're good at math? Yeah. And I like Rebirth Pages saying math is a different language. I loved math always, and I was pretty good at it once I had a good teacher. And I remember actually, I really wanted to write this like really snarky letter to one of my high school teachers because, and here we're done with this galaxy, but because he, when I was struggling with physics in high school, just said, well, I don't think you're good at this. Like, you're just not good at physics. And I really wanted to write him when I was in graduate school for astrophysics, like, you know, doing well in my classes and stuff, and be like, oh yeah? Like, really? Jerk. Don't ever tell people that. If you're teachers, don't ever tell people that they're just bad at it. I've never met someone who's just bad at something. Usually it's bad teaching. What telescope did we build? We built a small radio telescope to detect the cosmic microwave background. Oh, all right. So you're coming up with some algorithms for data integration across modalities for clustering graph-based trajectory inference. Biofocused. Okay. Yeah, please do. And graph-based stuff is really, really neat. I've only been able to do a little bit of it for work, but it's something that I am going to do a whole session on as well for this 12 days of machine learning miss, because I've done some of it on my own for passion projects, but it's really, really cool. Actually, since you're doing bio stuff, there's some really cool genetic algorithms that I've seen applied to reinforcement learning in really, really cool ways. So I think were originally designed to do modeling of, like, I don't know if it was like genetic mutations. I'm not a biologist, so. But then eventually, and this is the beautiful thing about machine learning, and also the dangerous thing, right? Is that you can have an algorithm that you build for one specific purpose, like, I don't know, modeling genetic mutations or something. And then somebody can take that same structure and be like, wow, this actually has applicability in something completely different. And so I saw it applied to modeling relationships essentially between players in team-based sports. And so like the complex kinds of evolving relationships, well, it was for a video game, but still I think team-based sports makes enough sense. Modeling the complex relationships between different players. And it was really, really cool. Like, it was something I really wanted to build. I ended up not having time, but very cool that it came from biology and had this application to video games of all things. Oh, all right. So, it's about 9 o'clock. So I think to keep my stamina and my cold at bay, I'm going to get Tennessee to sing for all of you. Please don't leave, because this is like, Tennessee is way cooler than I am. Thank you. Oh no, it looks like I missed Entropy Maximizer. Thank you for following. And also Haskins Dustin. But he sings sci-fi TV show themes, and you all can choose. So Loafbone, our wonderful mod, can you please create a straw poll, since the stream polls have been shitting themselves, and put our normal Star Trek or Stargate songs. I will take down my green screen, so hopefully you can see him, obviously, and I'll go get him and his bribe, which is usually a piece of cheese. And when I come back, we'll have Tennessee sing for you. So please don't go anywhere. He's worth the wait, I promise. He's amazing. Who doesn't want to see an adorable, cute little dog singing their heart out, right? Okay, vote and everything. I will be right back. All right, let's see what everyone picked. All right, TNG again. You all kind of are a little predictable, I'm not gonna lie. And I actually don't think I need to mess too much with the filters because it looks like I don't have a lot of weird green chroma stuff that it would pick up on. Oh, but I do need to remove the filter that is the, okay, 10, I love you, stop. This, so you can see him a little better. Okay. So small microphone warning here, or volume warning. He is very, you can hear him, he's very loud. So I'm gonna turn the mic down a little bit. No thanks, I don't want YouTube TV. Okay. Let's put this over here so you can see the diva himself. Prepping his voice. All right. Oh, he's so ready. All right, let's move this. All right, friends, here you go. Low phone, find somebody for us to raid. Okay. Very good boys. You can say hi to Stream. You're both very good boys. Oh, good sit. I don't have any more treats. I'm sorry. Hubble touch. Good boy. Hubble kiss. Thank you. Good boys, paw. Yeah, it is a good paw. Good boys. Oh, thank you for the kisses, Tim. Very, 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 very good pups. Let's still have this little down so that you can see them. So let's see. Yes, so actually he does sing differently to different songs. And he wasn't Pavloved. That's the funny thing. He did this without any provocation. So he wasn't trained to do it. It wasn't like a trick. He doesn't even do it on command. He only does it to songs that he likes. So he just feels the music. And here's the funny thing, right? So I don't know anything about animal musical ability, right? If you play the Star Trek theme on piano, he sings to it. He recognizes it and he'll sing to it. It's absurd. And he sings differently. Like sometimes you'll see like he'll get overly excited because like the music's gonna swell like 5 seconds from then. And then he jumps the gun and he starts like yodeling or whatever a little bit early. But sometimes like you can hear him trying to like match the pitch and trying to like catch the pattern. And if it's a new song, he'll stop a lot more and like listen and be like, what does this sound like? And try to sing along. and is the cutest thing. Seriously, like, he's freaking adorable. He's a magical pup. Machine learning tool that sings as a dog to songs. That would be cool. He's a reinforcement learning boy, constantly learning how to maximize his reward function. Don't worry, we'll get there, chat. So we're gonna do a raid, all right? Please, as always, thank you for coming by. Come tomorrow if you want to learn more about classification. The schedule is both on our Discord and on Twitter, so more than able to find out what days to come if you want. You should come to all of them, though. But with raids, please try to stick around. Like, say hi, throw a follow to a small stream. Like, I try to only raid smaller streams. So let's spread the love a little bit, all right? And I will see you all tomorrow. Have a good night. Let's see. Oh, no, wait. It's not going. Did I goof it? I'm so bad at rating. Did I do it? Yes, I did it. There's a countdown. I didn't make an ass of myself. All right, let's go raid.